Assalamualaikum and good morning. Today we are from Group A3 and will present about the problem and limitation of epoxy and copper as metallic filler used for the electronic industry.
Project summary. In our report, we will discuss on the properties of electrically conductive and thermally conductive nanocomposites that are suitable for electronics. We will review on the material development of nanocomposites, namely by microwave technique. The electrical conductivity of the said nanocomposite will be evaluated by two-point probe method, which is indicated on the top right picture, and four-point probe method. Meanwhile, to determine the thermal conductivity, we will be using guarded heat flow meter, surface probe method, transient pulse method, and flash pulse measurement system method. And finally, tensile tests are conducted to gain the Young modulus compressive strength, tensile strength, and modulus of elasticity. Simply to say, the tensile test is to get the mechanical property of the said nanocomposite.
For the part composite, definition of composite. A multi-phase solid material, one of the phases have one or two or three dimensions of less than 100 nanometers, or the structure having nanoscale repeating distances between the different phases that make up the material. The solid phase can be amorphous, semi-crystalline, or crystalline, or the combination of them. They can also be inorganic or organic compound or both, and essentially of any composition. The idea of behind the nanocomposite is to use building blocks with the dimensions in nanometer range to design and create the new materials with the unprecedented flexibility and improvement in their physical properties. Nanocomposite is more usually taken to the mean of the solid combination of a bulk matrix and nano-dimensional phases differing in properties due to the dissimilarities in structure and chemistry. Nanocomposites are also pervasive throughout the biological system. Only few were man-made materials such as intercalation compounds, graphite intercalation compound, pellet clays, and clay organic complex. In the biological world, plants form nanocomposites with the accumulation of significant amount of inorganic components such as Si, Ca, and etc. at the tissue and cellular level to deal with the mechanical and biophysical demand of their survival. Application of nanocomposite: oil and gas pipeline, automobiles, aircraft, electronics, films, environmental protection, food packaging, and also fuel tanks. Mechanically reinforced lightweight components, non-linear optics, battery cathode and ionic, nanowires, sensors, and other systems are also the application of the nanocomposite. In automotive, it's including door handles, engine covers, and intake manifolds and timing belt covers. More general applications currently being considered include uses as impellers and blades for vacuum cleaners, power tool housings, mover hoods, and covers for portable electronic equipment such as mobile phones, pages, and etc.
Material development. So the materials development of the epoxy copper nanocomposite strongly relies on the formulation of the synthesization of both materials, as this influence the electrical and the thermal properties of the composite. So those properties are actually influenced by the size, the type, the content, and the shape of the filler, which resulting in the use of filler dispersion enhancement technique inside the matrix. These are the example of the filler dispersion enhancement technique. However, in the application of the epoxy CU composite, it is advisable to use aqueous phase technique. This gives the opportunity for the metal particle to be transferred from the aqueous phase to organic phase. This is because the nano-sized CU particles has uniform morphology and well dispersed inside polymer matrix in aqueous phase condition. by referring to Muhammad Himizi in 2012. Those are the procedures for the aqueous phase technique. The first one is actually the use of epoxy as organic media after being dissolved in toluene, and then add 2 ml of 7.95 power of -2 CTAB into the 0.5 ml of aqueous phase Cu2 plus ions for stabilization. And then, by using 2 ml of sodium borohydrate, which is NaBH4, as reducing agent, the Cu2 plus ions will then be reduced to metal particles. For the transferring of the Cu particles from aqueous phase to organic phase, 5 ml of isopropanol IPA is used as the transferring agent. The organic media obtained earlier will then be added to the Cu hydrosol. The mixture is left evaporates via rotary evaporator at 70 degrees Celsius. An addition of 0.25 mole equivalent of NDA completes the preparation for the curing of the mixture. The curing process is held for 4 hours long at 150 degrees Celsius for the complete forming of the composite. For the example of epoxy Cu development on other application, which in this case is microwave application, it is advisable to use hydrocyte carbonate co-precipitation method, which involves the stoichiometric amount of nitrate salts of Cu and CO, which are dissolved in distilled water with the addition of saturated Na2CO3 solution. The application of hydrocyte carbonate co-precipitation method is considered because of its cost effectiveness and eco-friendly. Okay, to get a complete precipitation of metal ions as metal carbonates, the solution should be constantly stirred at 60 degrees Celsius and then filtered and also dried at 120 degrees Celsius for a whole 24 hours. For the epoxy resin use, it is advisable to use LY556 polymer matrix, which is synthesized by powered shear mixing. The powered shear mixing helps in reducing the particle size, dispersion, emulsion, expansion of nanomaterials in order to bring out the one-phase transfer for uniform distribution of nanomaterials. At a certain loadings, nanoparticles of copper cobaltite are dispersed around with the weight percentage of 3, 5, and 9%. And then 3 different curing processes will be held for the CuCO2O4 or copper oxide, epoxy resin, and both materials as nanocomposites. That's all from me. Thank you.
Material characterization of epoxy and copper. The properties of the material are as below. Epoxy is an insulator to electrical conductivity and has a low conductivity to thermal, but epoxy is well known to have a high strength and a versatile material. Meanwhile, for copper material, it has both good conductivity toward electrical and thermal. There are two types of test method for electrical conductivity, which is 2-probe method and 4-probe method. The setup and schematic diagram for both methods are shown in the table below. The function for 2-probe method is to use in a moderate resistivity range with acceptable precision. Meanwhile, for 4-probe method, it is to test low electrical resistivity at high accuracy. For 2-probe method, a screening test was performed first to estimate approximate resistivity of sample. If it falls into 10 exponent -1 to 10 exponent +6 cm, multimeter can be used for measurement. Meanwhile, if it falls into 10 exponent +3 to 10 exponent +70 cm, instead, a high resistivity will carry out the test. If it is in between, either equipment will work. Then, a test voltage is applied to the sample. Increase the test voltage until the resulting current can go through sample so that the reading of resistance of resistivity does not change. The test voltage and subsequent current are recorded. If tested by multimeter, sample resistivity is then calculated by standard resistivity equation. For 4-probe method, a silver wire is placed on 4-probe of the test fixture before taking the measurement in order to discharge the small amount of static electricity in the setup. The voltage and current of the power supply is weak. For a line, the sample whose resistivity is to be measured along the direction of magnet, The multimeter should be set at a high accuracy range. Once the current is passed across the sample, LabVIEW automatically recorded the voltage across the shunt resistance and the sample every 0.025 seconds. The current is then increased gradually to get the potential different for at least 100 different values. Usually, current should be kept lower to prevent plastic film melt by the heat accumulated in sample. There are three types of test methods that can be used for thermal conductivity: the guided heat flow meter, the transient pulse method, and the flash pulse measurement method. The schematic diagram for all of the methods are shown in the diagram below. For guided heat flow meter, the sample and a heat flux transducer are sandwiched between two flat plates controlled at different temperature in order to produce a heat flow through the step. A cylindrical guard surrounds the tester and is maintained at a uniform temperature of the two plates in order to minimize the lateral leak of heat. At steady state, the difference in temperature between the surface contacting the specimen is measured with temperature sensor embedded in the surface together with the electrical output of the HFT. The output voltage is proportional to the heat flow through the specimen, HFT, and the interface between the specimen and the apparatus. The coefficient of thermal conductivity can be obtained by prior calibration of system with the specimen to know thermal conductivity. For transient pass method, the sample is placed in the isothermal chamber consisted of the three paths of cylindrical shape. Between the first and the second part, the heat source was placed between nickel volume 20 micrometer thick and radius 2 cm. Between the second and third part, one connection of differentially connected thermocouple was placed. The second connection was placed on heat exchanger where the constant temperature was kept with the help of thermostat. The temperature is then measured in terms of the platinum resistance. Heat is supplied as a reticle current pulse from the software-directed source and the response are computed from the parameter of pulse. The change of temperature was measured by nanovoltmeter. Finally, for flash pulse measurement method, the phase of the FRP sample will be exposed to the short path of radiant energy and the thermal diffusivity of the sample is determined by considering the travel time of heat passed through the section of the sample. Tensile test was used to measure the mechanical properties of the sample. The type of tensile test used is ASTM D3039. Which is to measure the force required to break the polymer composite specimen and the extent to which the specimen stretches or elongates to that breaking point. Samples are placed in the grids of a universal test machine at a specified grid separation and pull until failure. For ASTM D3039, the test speed can be determined by the material specification or time to failure, 1 to 10 minutes. A typical test speed for standard test specimen is 2 mm per minute. An extensometer or strain gauge is used to determine elongation and tensile modulus. Depending upon the reinforcement and type, testing in more than one orientation may necessary. The schematic diagram is equation involved to find the mechanical properties of the sample. First is to use the Young modulus, the tensile splitting strength at failure, composite strength, tensile strength, and modulus of elasticity. The formula.
So that's all at the end of our project. Okay. As the conclusion for our project, the most suitable adhesive to use in electronic industries is epoxy resin, and it is one of the most used polymers in manufacturing industries. Furthermore, epoxy, one of the glycolide groups, can be cured by forming from the usable materials. In addition, composite with the polymers matrix PMC with combination of the unique characteristic can be exhibit with the combination particles such as thermal conductive, dielectric constant and ductility, scratch resistant, and the modulus. Toughness and wear properties impact performance and the compressive strength. By then, the transfer efficiency of the metal particle is about 95%.
The TEM analysis reveals that the in-addition of the epoxy and MDA plays the role of the Cu nanoparticles regulation of the size and depression. A slight decrement of the thermal ability is observed for the Cu epoxy MDA composite compared to pure unfilled epoxy MDA. This report was solved by the problem and the limitation of the epoxy and copper as a metallic filler used for electric industry. So I will tell this all that's all for our presentation. Thank you and Happy New Year.